Chapter 2, Reasoning and Proof, Section 2, Conditional Statements. To start off, I'm going to give you a little bit of background on truth values and simple statements, compound statements, everything that builds up to conditional statements. So starting off, compound sentences or compound statements are formed by connectives. So you'll have a simple statement and a simple statement. So you're connecting two simple statements to each other. A conjunction is a compound statement formed by combining two simple statements using the word and. So if you have the simple statement P, which is a rose is a flower, the simple statement Q, a cat is an animal, P and Q, the symbol stands for and, it looks like an A that's missing the line, would be a rose is a flower and a cat is an animal. So that's a conjunction when you combine two simple statements with the word and. A disjunction is a compound statement made from joining two simple statements using the word or. So you have a simple statement, Catherine walks to school. Another simple statement, Sally drives to school. Together, P or Q, Catherine walks to school or Sally drives to school. So we have two types of compound sentences or statements here. Conjunction uses the word and, this is the symbol. Disjunction uses the word or, here's the symbol. So this is called a truth table. Now, I'm going to show you how to determine whether or not something is true or false. But if you're better at memorizing, this is a different way to think of it. So this is what we call a negation. So meaning this is a simple statement. If it starts out as true, if you negate it, it becomes false. So let's say I start with a simple statement, the sky is blue. Well, that's true. The negation of that would be the sky is not blue. That would be false. So this is just telling you if it starts out as true, the negation of it is false. So now we're going to talk about all of the different types of conjunctions. So here we have two simple declarative statements. I am a teacher, I like math. It's telling you something. They can't be questions, they can't be exclamations, they have to just be declarative sentences. So I'm working off the basis that these two simple statements are true. So let's start filling in the truth table logically. So starting with the first example, P and Q. So basically, if P is true and Q is true, that means P and Q is going to be true, which makes sense. I am a teacher, I like math. Both of those are true. The conjunction would read, I am a teacher and I like math. That whole statement is true. Now what if we look at not P, so the negation of P and Q? Well, if P started out as true, then the negation of P is going to be false. Same thing for the negation of Q. So now we're looking at not P, which is false, and Q. So I am not a teacher and I like math. Well, this whole statement is not true because saying I am not a teacher is false and I like math. So what I'm saying is false and true, which is false. Same thing for the next example. I am a teacher and I do not like math because it's the negation. That's also false. And then I am not a teacher and I do not like math. That's two false statements, which is also false. Now we move on to disjunctions, so or. So the first one is P or Q. So I am a teacher or I like math. That means true or true, which is true. I am not a teacher or I like math. That means false or true, which is also true because one of them is correct. I am a teacher, or I do not like math. Again, one of them is true, so that's true. And then I am not a teacher, or I do not like math. Well, neither one of those options are true, so that disjunction is false. So you can see that when you have two things that are true, that means that the conjunction of them will be true. If you have a true and a false, the conjunction of them have to be false, because when you use the word and, it means both simple statements have to be true. And obviously, the conjunction of two false statements has to be false. When you're working with disjunctions, the word or, one or the other has to be true. So these were both true, so it's a true statement. This was false and this was true, but one of them was true. True and false, the whole thing is true. Both were false, so the final is false. So when you have a conjunction, the word and, they both have to be true. When you have a disjunction, the word or, one or the other has to be true. So now let's just fill in the rest of this truth table. So now we have the rest of our table filled in. We have our conjunction section and our disjunction section. And you can see that the reason we have these 4 rows here is because it's saying if you start off with 2 true statements. If you start off with a true and a false and a true, or 2 false. So if you start off with 2 false statements, so if I tell you my calculator is broken and the other simple statement is I don't have a dog, both of those are false statements. So I'm starting off with 2 false statements, so it changes the order of which are false and which are true. Now, you don't have to memorize this table because you can use common sense. You can use logic to figure out the truth value of a compound statement, of a conjunction or a disjunction. So that brings us now to conditional. A conditional is a compound statement formed by using the words if, then, or sometimes a variation of that, to combine 2 simple statements. The part that follows if is called the hypothesis. It's the premise or the antecedent. It's the sentence that begins an argument. And the conclusion or the consequent is the sentence that closes an argument. So this means P implies Q. So it would be written as if it is January, and it is January is P, then it is winter, and it is winter is Q. So you have if then, it is January is the hypothesis, it is winter is the conclusion. P implies Q. It could be written as it is January, implies that it is winter. Again, we have our hypothesis and conclusion. And P implies Q. It is January only if it is winter. Again, hypothesis and conclusion. Keep in mind that you might sometimes get a sentence where the hypothesis and conclusion are mixed up and you'll have to write it as a conditional. You have to write it as an if-then statement, so don't let that fool you. So this brings us to a little bit more about truth value. So truth value is when we can determine that a statement is true or false, and if the statement is false, you can prove so with a counterexample, which we've already talked a little bit about. So let's say we're given the conditional, if a number is divisible by 3, then it is odd. What is the truth value of this statement? Well, let's just think of a few examples. What numbers are divisible by 3? Obviously, evenly divisible by 3 would be multiples of 3. So 3, 6, 9. Right off the bat, right there, we said 3, 6, 9, 12. These are all divisible by 3. Well, 3 is odd, but is 6 odd? Is 12 odd? The next would be 18. Is 18 odd? The truth value here is going to be false. But we can see a number is divisible by 3. If this is true, then it is odd. Well, what if this last statement is false? Since 6 isn't odd, we're going to see that if something that's true implies something that's false, then the whole statement is false. And our counter example would just be 6 divided by 3 is 2. So this is divisible by 3, and the number 6 is not odd, so 6 is even. Now the negation of a statement is the opposite of that statement, so again we've talked about that a little. It's usually fairly simple. If you start off with a simple statement, the sky is blue, the negation would be the sky is not blue. So you usually just add a negative word, not, never, is not, something along those lines.